things are becoming more interesting now. This set of cons are about functions, and as we can see here, we have a couple of functions defined. So add 1, x equals x plus 1. So as the name suggests, this function just adds 1 to whatever parameter it's receiving. It is receiving. So now here we can see function type signature. This add function takes a number and another number and then returns a number. So add x and y just adds them, subtract. So there's another way of defining a function by just binding this name to this nameless function. Okay, now subtract from 4. This only takes one parameter and then returns a number. So it uses subtract, this guy here, but it supplies it with the number 4. So this is a partially applied function where the first parameter is 4. Always 5. Wondering if this must be, yeah, it doesn't appear anywhere in the document, so this must be a function that does something. I'm not sure. If we look at the type signature, it says A to B to A. Okay, so it takes two things and then it returns the first, I guess. I guess we'll see. Flip. So flip. So the first argument to flip is a function actually, and this function is from A to B to C, and then it takes the second argument as B, the third argument as A, and then it returns C. I'm not quite sure. I think I know what flip does, but I can't interpret this type signature yet, so guess we'll see. So multiply by 2, as the name suggests, just multiplies its argument by the number 2. Alright, let's dive into these cons. So the first one says the identity function returns whatever it is passed. So identity 4 should return 4 because the identity should not change anything. It just returns whatever it is given. Functions are defined as name args. Oh, so this is like a comment inside the comment. Let me turn off the syntax checking. So you just have a name and then the arguments and then equal and then the body of the function. Makes sense? So add 1 with something should equal 5. So we know that add 1 takes a parameter or an argument and then it adds 1 to that parameter. So to get 5 using this function we have to supply it with 4. So 4 add 1 4 should be 5. That is correct. Function may have an optional type signature. Okay, so this is 3 and 2 should be 5. But what do they mean by an optional type signature? I know that you can define the type signature like this, like before the function definition. But can we do that inside the lambda? guess let me try something like this. No. How about this? No. Let's see. I can always say add 1. Which takes an int to an int. But we can't put that here. I guess this. Let's try this here. No. How about here? No. How about here? I'm insisting on figuring out what do they mean by an optional signature type. Oh, sorry, it's a God. So it's in the second one. Maybe when we have a function with all arguments. No, that doesn't make any sense. Okay, let's read a single colon is for type annotation. Maybe you want double colon. Maybe you are defining a type annotation, but there is a white space before it. So I'm defining a type annotation. What do they mean by there is a space before it? I'm not sure really. So functions may have an optional type signature. Now it's complaining about the white space before it. Yeah, I'm wondering how can we add the type signature like in line. I don't know. Okay, let's move on. If I figure something out, I'll add it to the end of the video. Sorry about all that time of me fiddling around trying to figure this out. So anonymous functions are defined with / and then the arguments and then arrow and then the implementation or the body of the function. So subtract 8 from something to equal to 5. So if we subtract 2 from 8, I mean 3 from 8, really bad at arithmetics by the way. Anonymous functions may be defined in line. Yeah, so we don't need to have a name really for these tiny functions. So this is just our subtract function. So 8 minus something should equal to 5, so this should be 3. Functions past some values return curried functions. Yeah, these are the partially applied functions. So subtract from 4 is the function subtract with 4 supplied as the first argument. So it's like saying subtract 4 and then what number to equal to 1. So this must be 3. Okay, the always function returns its first argument no matter what the second. Oh, I see. So this is always, so no matter which argument this function gets, it will always return the first argument, which was 5 if I recall correctly. Yeah. So, but again, notice here that we don't always 5 does not accept named parameter, while here we are passing 4. So can I say 5 again? What? Oh, I see. So always itself is expecting 2 arguments. So we already got 5, and the second one in this case was 4, so it will return 5. Okay, the flip function flips the order of the first 2 arguments of a function. Oh, I see. So subtract 4, 9. So this function flips subtract and gives it 4, meaning that it's like when you call subtract 4, it's like calling subtract and then 4 being passed in place of the y variable here, because the arguments are flipped. Okay, so subtract 4, 9, it's like saying 9 minus 4, which should be what, 5. Okay, now f backpipe a applies the function f to the arguments a. So here we have add 1 and 9, which evaluates to 10, and then that whole thing has been passed to subtract 4, so it's like saying 10 minus 4, which should be 6. Okay, now this is going the other way around, so yeah, we've already seen this operator, so this will be the same value. Okay, now we have double less than, so G, I guess we'll call it compose, so G compose F composes function G with function F. Okay, so we have the highlight section here, composes subtract 4 with multiply by 2, so it's like saying subtract 4 first, then the result of that operation multiplied by 2. So when we pass 9 to 4 to this function subtract 4, the result was what? It was 5, so 5, and then we multiply it by 2, we get 10. Here we go. And here it's the same thing, but it's going the other way around, so this is from left to right and this is from right to left. And this should also give us the same value. Whew. That was a bit of a long one, but we got that down.